So what is a thermistor? A thermistor is simply a resistor that is sensitive to temperature change. So as the temperature changes, the resistance changes. There are two types of thermistors. NTC, negative temperature coefficient, which means as the temperature rises, the resistance will drop, and PTC, positive temperature coefficient, which means as the temperature increases, the resistance will also increase. NTC and thermistors are more commonly used for temperature measurements. The first ever thermistor was created by Michael Faraday in 1830s while he was studying the behavior of semiconducting materials. Through his study, Faraday noticed that silver oxide and other materials can change their resistance drastically depending on the temperature that they are exposed to. In the early days of the thermistor, they were very difficult and expensive to manufacture. In addition to that, they did not have many uses. Because of that, the now commonly used thermistor design was invented only in the 1930s by Samuel Rubin.
The thermistor has many advantages and many disadvantages. The main advantages of a thermistor is that it is inexpensive. It is also capable of measuring changes in temperature really fast. Also, it is very good at accuracy within the given range that it can measure. The disadvantages of a thermistor are that it is limited to a maximum temperature, usually about 350 Celsius, but it depends on the material used. Another disadvantage is the resistance to temperature correlation is nonlinear. It is in fact logarithmic. And the last disadvantage is that it can self-heat, causing inaccurate temperature readings, which can be very detrimental in really specific situations.
NTC, negative temperature coefficient thermistors, due to their ability to decrease resistance value as the temperature increases, are commonly used in inline inrush current limiters. They work by being placed in a part of the circuit where the current is being supplied and quickly heat up, automatically reducing their resistance. This helps the circuit automatically regulate itself by letting more or less power go through depending on the voltage. PTC, positive temperature coefficient, are commonly used as restable fuses. Like NTC transistors, these also automatically increase their temperature based on the voltage flowing through them. This fact can be used by creating a big enough resistance once the certain voltages have been reached. These types of applications can be found in various household objects like phones and computers.
In addition, thermistors are also used as temperature sensing devices in various industrial applications. One of these applications is as a health monitoring device, such as a thermometer and ECG monitor, as well as in water quality monitoring systems. They are also used in agriculture. There, thermometers are used to measure plant respiration, which is affected by temperature, humidity, and carbon dioxide concentration.
The construction of thermistor. Many thermistors are made from a pressed disc, rod, plate, bead, or cast chip of semiconducting material, such as sintered metal oxides. Over large changes in temperature, calibration is necessary. Over small changes in temperature, if the right semiconductor is used, the resistance of the material is linearly proportional to the temperature.
Inner workings. In its basic form, the thermistor consists of a semiconductor sandwiched between two conductors. The material used in the semiconductor determines the ranges of temperatures the thermistor can accurately measure. Wrapping it all in a protective coating or shell used to help the thermistor to last longer by not being exposed to open air and other physical interference.
They are often characterized by a maximum and minimum resistance and are usually rated in ohms. Any material with a relatively high heat capacity and conductivity, such as aluminium, copper, or silver, can be used as a thermistor. Solid-state thermistors are rated for the operating temperature range and have no moving parts, and so require no power. Thermistor sensor itself is a relatively small component. This makes it an excellent choice to place in either an application-specific or even low-power design.
The thermistor module in its most basic form is a simple thermistor consisting of the thermistor itself, a resistor to help smoothen the curve the temperature the thermistor provides from logarithmic to linear. In addition to the resistors, a thermistor module may also have a ground pin and a signal out pin, which can be used to get readings from the module to the Raspberry Pi, Arduino, or other device. More high-end modules may also include a built-in analog-to-digital converter and a microcontroller which calibrates the values so it has more accurate readings.
Wiring diagram. This wiring diagram is for SSH terminal output. As you can see in this picture, there are few components, 3 wires, DS18B20 thermistor, a resistor that is 4.7k ohm or 10k ohm. So as you can see, the black wire is connected to thermistor's ground, the blue wire is connected to data, and the red wire is connected to voltage in.
In the picture shown in this slide, we can actually see the Raspberry Pi output with given temperatures in Celsius and Fahrenheit.
Here we can see a simulation of how the thermistor works in a Tinkercad environment. We first connect everything according to the schematic and then run the code. As we can see, using the slider to lower or to up the temperature makes the values for the Fahrenheit or Celsius output different. This is basically how the thermistor works and is basically how it would work in a module.